11.3 is probability of multiple events, and we're going to have some new symbols and some new terminology and some new formulas to look at. So let's talk about this first of all. This symbol right here stands for the intersection. And so maybe you've seen a Venn diagram before. You've seen a Venn diagram, and it's usually, not always, but usually it looks like two intersecting circles. And the intersection is the overlap of where those two circles intersect. Okay, that is the intersection. And I will read that as the probability of A and B. So when you hear me say the word and, I'm talking about the intersection. Okay, what is in both of those sets? So if I said, I just drew 5 symbols right there, right? Okay, and let's draw. Okay, now I've got 10 symbols, 5 of which are purple and 5 of which are green. Okay, how many of those symbols are both purple and plus signs? 2 of them, right? Okay, so I might have, if I was drawing my Venn diagram, I might say, okay, well, these are the purple ones. And so minus, 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 plus, plus. Okay, so you've got, I don't know if that picture is very good. I don't know if that's a good example or not. But anyway, you were right. The purple and plus signs would be these two. So that's what I'm talking about. Okay, the other symbol, this symbol is union. Okay, and union means or. I'll read it as A or B, the probability of A or B. And so if you go back and look at your Venn diagram, what's in either A or B would be basically the whole thing. Okay, any place, either side, in the middle, in the intersection, not in the intersection, anything in A or B or both is usually what I mean. Okay, so you got to know those symbols before we even start to look at some of the formulas. So independent events. Independent events are two events independent. We have a test for that, and we're going to look at this equation right here. Probability of A and B equals the probability of A times the probability of B. So get that formula down. That's how we check if that's if we're talking about two independent events. A and B are independent if this is true. All right. If this is a true statement, A and B are independent. If true, A and B are independent. So we've got a formula here. We're going to have like several more. Mutually exclusive. Mutually exclusive means there's no overlap. Okay, there's no overlap. If I said raise your hand if you're a senior, and then I said raise your hand if you're a male, then some people would probably raise their hand both times, right? Because there's overlap. But if I said raise your hand if you're a senior, now raise your hand if you're a junior, those two things wouldn't have any overlap because you can't be both at the same time. You can't be both a senior and a junior at the same time because those two events are mutually exclusive. So if I drew a Venn diagram for that, there wouldn't be an overlap. And we hardly ever see a Venn diagram like that, but that's mutually exclusive, okay? And there's a formula for that. The probability of A or B equals the probability of A plus the probability of B. All right. Now this only holds true if the events are mutually exclusive. If they're not mutually exclusive, we have to look at something else. So mutually exclusive has this formula. Okay. Union rule. The union rule will always hold whether they're mutually exclusive or not. The union rule is going to look like this. Probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. You getting that down? Be very careful and don't mess up the symbols. Okay, notice the difference between the union symbol and the intersection symbol. Now, this is the union rule. And it's honestly not that hard to memorize. It looks kind of complicated, but it's not that bad. The way I remember it is I call this first part a double, and I call this part a single, and then the other double is what I say, all right? So single meaning there's only one of them, double means there's two of them. The two doubles are interchangeable, and so you really can't mess it up. Because if I switch it around and say the probability of A and B equals the probability of A plus the probability of B minus the probability of A or B, that formula is also going to work. So as long as you've got double equals single plus single minus the other double, either way it's going to work. Then the last one is conditional probability. Conditional probability is this: probability of A given B equals the probability of A and B divided by the probability of B. Oops. So conditional probability is you're finding probability, but you've got this background information. All right. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of you in this room right now. So what's the probability that I pick one of you and give a piece of candy? I'll give one of you a piece of candy. What's the probability it's you? 1 out of 10, right? 10%. Okay. Now, what's the probability that I give it to you? Well, let's say this. What's the probability that I give it to Jackson? Okay. 1 out of 10, right? 10%. Now, check this out and listen for the difference. What's the probability that I give it to Jackson, given that it's definitely going to this row? 33% or 1 out of 3, right? Okay, so you've got extra background information. I still found what's the probability that I give it to Jackson, but I've got this extra information that changes the probability. All right, that's what conditional is. You're finding the probability of something happens, probability of A, given that we've got this extra background information. All right, so that's conditional probability. It has a partner, I guess, that might be useful for you to use if you just kind of rearrange the terms. I suppose you could say probability of A and B is equal to the probability of A given B times probability of B. So you've got a whole bunch of formulas there. You need to get all those down. If you get all those down, if you have all those formulas, then this lesson shouldn't be that tough. Okay. If you want to take a picture of all these formulas right here, that's fine, but you're going to need these formulas when you look at the assignment. All right. So I'll give you about 5 seconds, unless you have them all written down. All right. Well, let's look at some problems. These should not be the same as what you have on the front side. These are just different ones, okay? So you've got those formulas out in front of you, right? Problem 1 says determine if events A and B are independent. So think about what we know here. In order to be independent, we have to have this is true, okay? That has to be true. That has to be true. And so really all I'm going to do is I'm going to say 0.24 equals 0.4 times 0.6 question mark. All right? I'm saying is that a true statement? Okay? So 0.4 times 0.6 is 0.24. That's true. All right? That's true. So what does that mean? Independent. Okay? So if we look at number 2, it's the same thing. We want to see if A and B, 0.0875, is equal to A times B. Is that true? So question mark. I'm asking myself a question. Is that true? Well, 0.25 times 0.25 is not the same thing, right? That's 0.0625. So 0.0875 equals, that's false. Okay, that's false. So guess what? Dependent. Yeah, I already told you that. It's not the same problems. That's why you're on the backside. Okay. Now, problem 3 says events A and B are independent. So it's telling us it's true. We know this is true. Well, we've got a formula for independent. That formula for independent is probability of A and B equals probability of A times probability of B. They're telling us that this is true. So we know this is true. So let's just plug in. Probability of A and B is 0.125. Probability of B is 0.5. They want to know the probability of A, so let's just call that X. All we do is solve that equation. So how do I solve that equation? Just go back to your algebra skills. We're going to divide by 0.5 to isolate the variable. 0.125 divided by 0.5 is 0.25. X equals 0.25, or rather we should say probability of A equals 0.25. Problem 4 is easier because they want this one. So probability of A and B is equal to probability of A times probability of B. Well, they're giving me A is 0.6 and B is 0.35. So all we're doing is multiplying. 0.21. Probability of A and B equals 0.21. What we're doing in this lesson is figuring out which formula to use, plugging in the numbers that we have, and finding the one that we don't, pretty much every single time. Determine if events A and B are mutually exclusive. So mutually exclusive. They're trying to tell you which equation to use. Mutually exclusive says probability of A or B equals probability of A plus probability of B. That would have to be true in order for this to be mutually exclusive. So we can say the probability of A or B equals the probability of A plus the probability of B question mark. Or maybe I should have just plugged it in. 0.775 equals 0.5 plus 0.55. Can you tell if that's true or false without a calculator? 0.5 plus 0.55. That's not true, right? That is a false statement. So what does that mean? Not mutually exclusive. All right, so basically all we have to do is say 0.65 equals 0.4 plus 0.25 question mark. Is that a true statement? We can tell that's true, right? That's true. So these are mutually exclusive. Okay, find the missing probability. Notice what you've got. In these problems, I've got, they want one of the doubles and they give me one of the opposite doubles. That's a pretty good indication that this is going to be union rule. Union rule says the probability of the union equals the single plus the single minus the double that they didn't ask me about, right? So I'm doing 0.4 plus 0.25 minus 0.1. I'm just using the equation. That's the union rule. So 0.4 plus 0.25 minus 0.1 is 0.55. Probability of the union is 0.55. That's the union rule. Number 8 is the same thing, right? They want the double. They give me the other double. We've got these singles. It's the same thing. Let's skip that one. Okay, number 9 is conditional probability, and you can tell it's conditional probability because of this symbol right there. Okay, that is conditional, and that says given. That's the one where you've got this extra background information. I'm finding the probability of A given that B has already happened. All right. So conditional probability is probability of A given B equals the probability of A and B over probability of B. So, oh, you know what? This is the one where they want this. So this is where I actually used the other formula. Basically, it's like I'm cross multiplying almost. I can see the probability of the intersection would be equal to the probability of A given B times probability of B. So I've rearranged my equation. I've used the second version that I gave you earlier, but all we're doing is saying 0.15 times 0.6 is 0.09. And then the last one, notice they switched it around and put B given A. That's fine. You can really put any of the letters anywhere as long as it follows this pattern, okay? So probability of, normally what you would say is B given A over probability of A. But B given A, if I said Bob and Andy or Andy and Bob, it doesn't really matter which order that's in. So they're giving me the probability of A and B is 0.0375. The probability of A was 0.25. So all I'm doing is dividing 0.0375 by 0.25, get 0.15. Probability of B given A equals 0.15.